Assalamu alaikum students, welcome to the world of physics. Today our topic is applications of Gauss's law. As Gauss's law provides a convenient method to calculate electric field E in the case of sufficiently symmetrical charge distributions. So there are three applications of Gauss's law. The first one is location of excess charge on a conductor. Suppose this is a conductor on which we have to find out location of excess charge. As we know that electric field E is equal to 0 inside the conductor. E is equal to 0 at all points inside the conductor. Now we can make an imaginary Gaussian surface S in this way. This is the Gaussian surface in which I will take a point P. This is the point P. This is the Gaussian surface. Gaussian surface. Now we have made this imaginary Gaussian surface S. Its name is S. This is imaginary Gaussian surface S in the interior of conductor because this surface is present inside the conductor. And as E is equal to 0 everywhere in this surface, then the net charge also is equal to 0. As E equals to 0, then net charge is also equals to 0 inside the conductor. So where the charge will reside? All the charges will reside outside the conductor or on the surface of the conductor in this way. So in this way, all the charges or all the excess charges will reside outside the conductor and there will be no single charge inside the conductor. In the same way, this is a regular surface. Suppose I have no regular surface but there is some irregular surface like this shape. Again, there will be no electric field inside the conductor. There will be no charge inside the conductor. So all the charges will reside outside the conductor in this way. This is the way that we can say that all the excess charges will reside outside the conductor. Now suppose we have some different case like this, that suppose this is a conductor and I am going to place a charge inside this conductor. Say this is the charge which is inside the conductor. What about this charge? As I have put this charge Q inside the hollow conductor, now I will insulate this charge so that no charge can jump from one surface to another. For this insulation, I will draw this boundary, this imaginary boundary. This is again a Gaussian surface S, which I have drawn to make it separate from the outer surface. Now as this charge is positive, because of this positive charge, all the negative charges, as no charge can reside inside the surface, so all the negative charges will reside on this surface. So all the negative charges will reside on or over this surface. Why these are negative? Because positive charge is there inside the cavity. And just we can use Gauss's law over here. By using Gauss's law, the net charge is equal to 0 because there was no charge transfer between the charge and the conductor. Initially the conductor was uncharged, but when the charge Q was placed inside the conductor, then all the negative charges remain on this surface or outside this surface to maintain its neutral status. So the other surface must have a charge equal but opposite to the charge of this internal cavity. Suppose this is the internal cavity and this is the external cavity. If this cavity is carrying negative charge, definitely all the positive charges will reside on this surface. In this way, we have proved that all excess charges always reside out of the conductor or on the outer cavity of the conductor and inside a conductor wherever electric field is equal to 0, everywhere Q is equal to 0. Thank you very much.